Hello again. We are looking at the tutorial for work and energy in problem set C. This is going to be the work and kinetic energy theorem. And with this particular theorem, just remember that we're looking at uh, work, net work is equal to the change in kinetic energy. Okay, so this is the total work that is being done at the time. Okay, and we're looking at velocities in this particular case. Now, the work energy theorem, as we expanded it in class, we looked at it and we said, okay, it's also the change in potential energy too. Okay, so the change in potential energy, the change in kinetic energy, they're equal to each other. And the change in potential energy we're talking about is gravitational potential energy in this particular case. Right? So as we look at it here, I'm going to take a look at problem number 5 here. And problem number 5 says here, the summit of Mount Everest is 8,848 meters above sea level, making it the highest summit on Earth. In 1953, Edmund Hillary was the first person to reach the summit. Suppose upon reaching there, Hillary slid a rock with a 45-gram mass down the side of the mountain. If the rock's speed okay, is 27 meters per second when it is 8,806 meters above sea level, how much work is done on the rock by air resistance? Okay, air resistance. So we've got to remember. Okay, so the first thing that we're going to do is what we always do. We're going to write down what our givens are. Okay? So here, this is problem number 5. And the mass of my object is going to be 45 grams. Okay, and I'm going to call this distance high is going to be 8,848 meters. I'm going to call the next one distance low, and that's going to be 8,806 meters. The velocity that the rock reaches, I'm going to call velocity final, and that equals 27.0 meters per second. So as I reach this velocity here, it's starting from rest and then going to that speed. Okay. All right. Now remember this, that what we're looking for is work. Okay. So the work of friction. So the work of friction is going to be the work that is done through the net force, the actual kind of work that we do, minus the work of perhaps free fall. And in this case, it is going to be free fall. So this could be gravitational work if we want to call it that, but it's the work through gravitational potential energy. Okay. Because if it's in free fall, we don't really have resistance getting on it with an object that small for that distance. Okay. Now, if it's the total distance that's being covered here, then we're going to have a greater amount of resistance that comes. Okay. But what we actually have minus that resistance, if this is greater, then we end up with a negative value, and that negative value will give us the resistance, the work of resistance. Okay. All right. So what we're going to look at is this, that work, friction, is going to be equal to the change in kinetic energy minus the change in the potential energy. So when we work this out, work friction will be equal to 1/2 mv final squared minus 1/2 mv initial squared, and then that minus mgh high minus mgh low. Okay. So we can factor some of this stuff out. The initial velocity was 0, so that can be 0. Okay, so we can end up factoring a lot of this stuff out, but I'm not. I'm going to keep kinetic energy together, and I'm going to keep potential energy together. Okay, so what we're going to end up with is this. Work final, or friction, sorry, is going to be equal to 1/2, and I've got to change my mass from 45 grams to kilograms. So this equals 0.045 kilograms, because kilos 1,000. So I move my decimal point 3 places because it's 1,000. So we're going to end up with 0.045 kilograms times 27.0 meters per second quantity squared minus, I'm going to put parentheses there, and I'm going to just factor out the mg's. So it's going to be mg, sorry, let me cross that out. It's going to be 0.045 kilograms times 9.8 meters per second squared times 8848 meters minus 8806 meters. Okay, so once I have these all taken care of, this becomes 42 meters, 42.0 meters. So now let me take out my handy dandy calculator. And when I do my calculator here, I'm going to do the first part here. So 1/2 is 0.5 times 0.045 times 27. Now I got to square the 27. So I'm going to hit this key right here, that key, which is x squared. Okay, equals, and that's 16.4 joules. So work final, or work friction, sorry, equals 16.4 joules. And that's going to be minus what I get over on this other side. So let me clear this, and it's going to be 0.045 times 9.8 times 42 equals 18.522, but we're going to round it to 18.5. So minus 18.5 joules. Okay, and so my work by friction is going to be negative, and I'm going to go ahead and put in those numbers here. So clear this, 18.5, sorry, it should be the first one, 16.4 minus the 18.5, and I get negative 2.1. So it's negative 2.1 joules. So this is the amount of work done by friction. Okay, so that's my answer. Okay, so for this problem set, I want you to do 6 out of 10. Okay, and this one doesn't count. So it's really 6 out of 9. So good luck.